Greetings everybody around the world. It's time once again for Ancient Aliens Radio. This is the dedicated radio show for the cast of Ancient Aliens. Here we interview authors and researchers as an ongoing investigation into the ancient alien theory. Don't forget to like us on Facebook or subscribe to the YouTube channel Ancient Aliens Radio. Today I will be discussing the work of Christopher Dunn. Chris's Pyramid Odyssey began in 1977 after he read Peter Tompkins' book Secrets of the Great Pyramid. His immediate reaction after learning of the Great Pyramid's precision and design characteristics was to consider that this edifice may have had an original purpose that differed from conventional opinion. After further research and study of source material on various theories, Chris concluded that it may have been originally built to provide a highly technical society with energy. In short, it was a very large machine. Let me see, can I get Chris on the line? So I have with me now on the line Christopher Dunn from Arizona, I believe he's in at the moment, and we're going to be talking today about the Giza power plant. So without further ado, let's bring on our guest for today. Hi Chris.
Hello James, thank you for having me.
Sure, it's been a pleasure to get you on, Chris, it really has. This show's going to be unique for me in a way, Chris, for a couple of reasons. You know, not only are we both engineers and authors of ancient history stroke monuments, but my career is based in the energy industry and as an engineer. So your book's going to be about the Giza power plant, and yes. It's a fascinating and appropriate tie-in for me because it was just a joy to read, Chris. It really was like. So it's first, yeah, it's first published in '97, Chris. Is that correct, or '98?
98, yeah.
98, yeah. Mm-hmm. And it's still going today, Chris. With and yeah, that must be quite amazing to have that book still going, because not a lot of authors get that, do they?
No, that's true. I think, you know, I'm really fortunate to have a publisher that keeps books in print, you know, and
yeah,
it's really good. A lot of publishers will remainder a book, or they'll stop making copies.
Sure.
They just go for the larger numbers, but this book seems to be just.
Yeah, and you've had some recent discoveries that actually have relatively recent, that have enhanced the theory so it's the theory that you've presented first when you started to write the book, which took you a while, but it's been growing a while. I think it was Gantenbrink's door and stuff like that had only enhanced the theory further.
Yeah, even before the book, Gantenbrink's door discovery really helped, and then the exploration behind Gantenbrink's door in 2002, that was significant also. So the first exploration of the southern shaft in 1993 by Rudolf Gantenbrink was included in the Giza power plant, and in the Giza power plant there was a prediction of what may be found behind that door, or so-called door.
Mm-hmm. Yeah, they've nicknamed it a door, I think.
They nicknamed it a door for want of a better term, I think. So,
we're going to get into specifics, Chris, in a minute. I tell you what, we've got some new listeners, so just briefly, succinctly, let's just get a bit of your background, because this is crucial to your book, Chris. This is, if there was ever a crucial career background, I think it's yours, Chris, because you've got quite a colourful, enigmatic career in the engineering background. So just give us some brief specifics there, Chris, if you could.
Well, sure. I'm from Manchester originally, and I served an apprenticeship at Mather and Platts in Manchester, and then my career brought me to the United States, and then after arriving in the United States, my career took off into other areas. So I've worked as a toolmaker, as an engineer, as a manager. I managed a laser job shop in Indianapolis, and then was recruited by Danville Metal Stamping in Illinois. I worked there for about 27 years in various positions, including management. And recently retired, but was recruited by a Fortune 500 company to work as a consultant engineer, and that's what brings me to Arizona. Previously, I was in Illinois, so I'm just here for the week. I'll be flying back tomorrow. But my background is in manufacturing, and essentially my training and education is in workshop processes, practices. I'm a hands-on engineer, and I also work the board and also work the CAD system. So I've been at pretty much every level, from using hand tools to sophisticated 5-axis CNC machines and lasers and other non-conventional type metal shaping technologies.
Mm-hmm. So, yeah, and this is the thing, Chris, this is why it's so important for what you bring to the table. I say this all stands to you, yeah. It's really the eye that you have, as you say in the book, the trained eye that makes you see these things. Not that other people couldn't spend a bit of time and look at them, but your trained eye would see them for what they are quite quickly. And, let's just talk about some facts here, first of all, Chris, just for the listeners, because we're going to get into some of this stuff. The Great Pyramid that we're going to talk about today sits on a 13-acre base, perfectly level bedrock, which I know you go into. It's actually aligned to true north 5/100ths of a degree. It's the center of all the landmass on the planet of the polar circumference and the grid line. The cement that's used in the casing blocks is unable to be reproduced as well. It's got 2.25 million tons of stone. The relationship between pi and phi is encoded in it in fundamental proportions, and the list goes on and on, Chris.
Right.
But where you seem to tackle things, Chris, is you get into the precision measurements. That's really what I see you tackling first in the book. That really kind of makes you wake up to this monument. Is that correct?
Exactly. They say the devil's in the details, and before you can understand something, you have to know it. If you want to speculate on what something's for or present a theory, the first thing you have to do is examine it with closely, using the best instruments possible that you have available. So there seemed to be Petrie in the 1800s started that, but his instruments were not as sophisticated as the instruments that are available today. And he was a surveyor. So he did not use the kind of tools or instruments that I would use. But his eye was keen. His father was an engineer. He had a very keen eye, and he noted several really significant and startling facts about how the ancient Egyptians were cutting stone using lathes and circular saws and tubular drills and achieving these fantastic feed rates. And all of that information seemed to indicate that the ancient Egyptians were much more sophisticated and much more technologically advanced than what we've given them credit for.
If I'm not mistaken, didn't Petrie pick up the drill cores that nobody else wanted to look at? He seemed to have a trained eye too, albeit, what was he, 100 years ago this guy lived?
He wrote Pyramids and Temples of Giza in 1883. So he was actually collecting his evidence in 1881 in Egypt, and published his book in 1883. And one of the more famous, it became famous, I think, because I had an article published in 1984, and it was called Advanced Machining in Ancient Egypt.
Yes.
And I featured core number 7 in that article, and then it achieved prominence in the age of the internet when I was invited to discuss my theory on a bulletin board. Deja News. And so there was quite a debate that raged on for months about the validity of Egyptian cutting methods versus more advanced cutting methods that I was proposing. And I don't think that debate was ever settled, but and it's still going on because it's still a bit of a mystery. But at least that particular core, which I'll describe for your listeners, is
please do. Yes, please do.
It's like that they were drilling holes in granite using a tubular type drill, almost like a tree panning process, they call it.
Yes.
The drill left a taper on the hole and also a taper on the core. And the significant part significant bit was on both the hull and the core. You have this spiral groove that wraps around it, and the spiral groove indicated a feed rate of up to 100,000 per revolution of the drill.
Yeah.
That seemed to me to be an astounding
phenomenal speed rate. Yeah.
Phenomenal feed rate, not one that you would achieve conventionally.
Mm-hmm.
Considering that, the way we drill granite today, it would be maybe 2/10,000ths of a revolution in a feed rate. So I figured that they were probably using a more non-conventional means of drilling. I speculated that
ultrasonic, perhaps?
Ultrasonic.
Is that just a term they have, Chris, for the speed rate, or is it actually to do with pressure applied as well? Or is it combined?
Yeah, with ultrasonics or impact machining, the tool, the rotation of the tool does not cause the cutting action. It's the oscillation of the tool and any abrasive that you use between the tool and the workpiece. And so as the tool oscillates, it is constantly rubbing and grinding against the material with this abrasive in between it. And at that frequency of about 20,000 hertz, at that frequency, then the material actually responds in a way that is it would not normally respond in a conventional material removal process. Mm-hmm. Even with a conventional drill and common steel, the adding ultrasonics provides improvement in the in process. So that, of course, that is just a technical perspective from an engineering point of view. It does not really provide credence to the archaeological point of view. It's strictly technical. And so that's where I get into trouble, is because I provide a perspective from an engineer's point of view, but it does not square with what archaeologists or Egyptologists
But this is the thing that always gets me, Chris, that, if there's an engineered device or there's an engineering technology present, which the Great Pyramid is, it's an engineering marvel for want of. Why not apply an engineering skill set to figure this thing out? But as you say, in the book, the Egyptologists have this kind of dogmatic, stagnant viewpoint, and their old subject was very young in the 1880s. It was born in the 1880s now, and
right.
I mean, they made a lot of guesses, I think, and had to basically typecast themselves into a role, if you want. Would that be right to say?
Yeah, I mean, they also have to please their peer group. Mm-hmm. And so stepping outside what is acceptable to their own peers, would probably find themselves out of work.
Yeah.
And, I mean, among the engineering group, we have a lot of different points of view and arguments about how things should be done, how things should be made. And, as engineers, if other people don't agree with us, we go off and just go ahead and do it ourselves, or try our ideas, and then come back and present them.
Yeah. I think the thing with engineering is you usually have, that's I think what you said in the book, you usually have one or two or three more methods of doing the process at hand, and there's always that other way of doing it. With the Egyptology mindset is, this is one way or the highway, really, yeah?
Yeah, well, the thing is that in engineering, it's all about, does it work?
Yeah.
I mean, the proof of the pudding, right?
The proof of the pudding's in eating, that's
right.
correct.
Right.
That's correct.
And consensus on whether something would work is not as important in engineering as it is in Egyptology. They draw a consensus as to what something might mean. And, but that is not necessarily the scientific method. And really, they very rarely follow the scientific method when they are coming up with their speculations. I mean,
that's the thing about the book, Chris, that I loved so much, is that you applied the scientific method from day one. you seen stuff that wasn't adding up, wasn't being addressed, and again, you've been at it a while before you finished the manuscript, as you were saying, and it's almost a journey of discovery. You were bringing the reader on a journey of discovery through the book, as you were reverse engineering it through the years, the process, and just some specifics. I think you dispelled some of the mythology that the Egyptologists come up to, which is very important, but you did it in a very logical engineering mindset. You didn't address their faults as such. It was more to do with, well, that's not true engineering-wise. That's not true scientifically. And one example would probably be the 13-acre base that it sits on, that they reckon was leveled by water canals. But limestone being porous, as you point out, that couldn't be true, like.
No, just the conventional theory about the purpose and use of the Great Pyramid is full of problems. It doesn't explain a lot of the features that you find within.
I like to call it the pyramid as tomb theory, because it is a theory. It is a theory.
Yes,
Probably the least substantiated one at that.
Right, and actually, you could craft a really good argument that the features within the Great Pyramid themselves argue against the tomb theory. And, there's no way that you could actually conclude that this was a tomb based on the evidence that we find. Mm-hmm. And one of the misnomers about pyramids is that they are tombs, because there has been no original burial found in any pyramid in Egypt. Even those pyramids where mummies were found, they were interred later, much later after the pyramid was built.
So and there was different stages of pyramid building as well. There is what we call the third dynasty pyramids, the oldest ones, and then there was other levels and other stages of pyramid building after that. Yeah,
I mean, you do find different qualities of the total structure. Now, interestingly though, you could look at the Great Pyramid, and we know a lot about the Great Pyramid, and we talk about the casing stones being cut and matched within 10,000ths of an inch, which is...
I'm glad you mentioned that. The accuracy of the casing stones is one of the most quoted accuracies on the Giza Plateau, is it not?
Right, and 10,000ths of an inch is half the thickness of a thumbnail. But that precision and accuracy is found on what you might consider to be some of the lesser pyramids. And also the size of these casing stones can be found on lesser pyramids that you would may think were inferior. If you go to Saqqara and you go to the Unas pyramid of Saqqara, that has a casing stone that's about 25 feet long, and it has the same quality and same precision that you find at Giza. And so, to say that a different culture created these lesser type pyramids, they're smaller, they look like rubble, really, because they're in different stages of destruction.
Correct, yeah.
But you still find an amazing quality of masonry there, which I find that the timeline that has been ascribed to a lot of these structures in Egypt, the engineering signature or the technological signature on the blocks seems to argue against the timeline, which says that this work was done when stoneworking was in decline, such as one side at Saqqara again, the Serapeum, where you find these massive granite boxes down in these limestone tunnels,
which are a lot bigger than sarcophagi, if you want to call them boxes of the...
Right.
Yeah, they call them sarcophagi, but as you say, they probably had another function. But these things are quite big, aren't they? They're really big, these ones.
Yes, they're about 8 feet tall, 7.5 feet wide, and 13.5 feet long.
What did the Egyptologists say that they're for? Just out of curiosity, Chris, or because they're not saying there's bodies in them, are they?
No, they claim to be made to house the body of the Apis bull. or the carcass of the Apis bull, which was a sacred animal in ancient Egypt.
Mm-hmm.
But there have been no bulls found in these granite boxes. There were remains of bulls found in wooden coffins nearby, but not in the granite boxes. But the evidence that has been uncovered in these tunnels is so sketchy.
Yeah.
As far as the provenance of what was found, how it was documented, and what was concluded, and what evidence supported that conclusion, seems to be very sketchy.
I think the public are aware more so now that the Egyptologists have like a stranglehold on ancient Egypt, that they seem to hold all the cards and they don't let anybody see their hand, and that the level of control they have on not just the Giza Plateau but on all the monuments in ancient Egypt, that Egyptology is really, it's a science, they're like a species among their own, if you will.
Well, I think they certainly do have control of any archaeology that is being conducted. They have control of where you dig, essentially how the work is performed, and then they have control over how information from these efforts is released to the public.
Mm-hmm.
But as far as influence on the general public, the alternate views seem to, if you go to Egypt with a group of engineers or any kind of technicians, and you start to show them the different features of these monuments, the stone artifacts that are flat within 2/1000ths of an inch or 2/10,000ths of an inch. An amazing array of artifacts with complicated geometry and precision, and they immediately reject the Egyptologist story.
Sure.
Because their training forbids them to accept that the tools necessary to perform this work are in the ancient Egyptian toolbox. They don't exist in the archaeological record.
I'm just thinking of the documentary that you made, Chris, Revelation of the Pyramids, and I remember you doing some stuff for that. But first, just now that I mentioned that, I didn't know before I watched that documentary that the pyramid isn't actually got 4 sides. It's what they say has 8 sides. It's almost each side is actually concaved a little. There's it's like an 8 surface pyramid. Is that correct?
Yeah, it does. It seems to fold towards the
center line.
From each corner.
Which is even more complex a pyramid to build than a 4-sided one.
It would be, yeah. It would be.
The mind boggles at the engineering marvel. It just the more people study this, Well,
if you're involved in engineering and then you start to study the details, that's when you depart from the conventional story. It becomes it excites people because it awakens in them
well, that's right. It's a provocative mystery then,
Right, it becomes, there's more to our history than what we've been taught. What's the rest of the story?
Tell me about the granite coffers, as we call them. I know you stopped calling them coffers halfway through the book, but for the purpose of the reader, you did for the start. But and for want of a better word, inside the Great Pyramid there's a granite coffer. Could you give us a little bit about the precision of that, because that's really important too, Chris, isn't it?
Yeah, these are granite boxes. They have the one in the Great Pyramid has tool marks on it. It has saw marks on one of the sides, right? It also has a sign of how it was hollowed out, because it was hollowed out of a solid piece, and they were using round rotating tools, obviously, because there is just a
circular mark?
shallow circular cut that goes down about 3 inches. But the inside surfaces are extremely precise. I used a precision straight edge on the inside of these granite boxes.
I remember seeing you do that. That is just astounding when you put that straight edge to that.
Right. Right, in the Great Pyramid, in the Second Pyramid, Khafra, and also at Saqqara.
But of course, it's a 3D edge. It's an XYZ plane, isn't it? It's not just a square corner. It's a square corner going down into the copper.
Right. You have well, when you're looking at a flat surface, you are looking at 2D.
Yeah.
But then when you put the lid on top of it, such as the one at Saqqara, that's in the Serapeum, then you start looking at a three-dimensional assembly. And there's a significant thing about the boxes in the Serapeum is that you have two surfaces opposite each other that are perfectly parallel, and they're probably about 6 feet apart.
Right. This is considerable. It's considerable.
Yeah, I mean, just consider yourself to be in a small bathroom or something like that, and you're looking at the walls. It's like that. You look at this wall, right opposite that wall is another wall, and they're perfectly parallel with each other.
And it's a solid piece of granite. How hard is that to do? How hard is that to do today, Chris? Realistically, effort-wise.
You could do it. It would, we would have to build special equipment to do it. I mean, we do have the know-how, we have the talent. A special machine, what could be designed and crafted to do that work. It would take a lot of, very expensive. I contacted several precision granite artifact manufacturers in the United States, and they were in the business of producing precision surface plates, V-blocks, angle plates for manufacturing inspection rooms. They had laboratory grade, inspection grade, tool room grade work. And there was two of these manufacturers wouldn't even talk to me about the project.
Really?
Right. One of them got back with me and was very kind and said that, they don't have the tools or the equipment to make one of these. If they were to have to make one of these and make it in 5 pieces and then ship it and bolt it together on the site instead of out of a solid piece.
They wouldn't even answer you on a solid piece, would they?
And then they said that the granite would be enormously expensive. It would cost, and this was back in 1995.
Right.
And they told me that the granite that size would cost about $175,000. And
serious
the the shipping costs would be enormous too, because you have Department of Transportation charges with.
Mind just boggles, doesn't it?
Yeah. But that's today, and we would be stretched to create something like
and this
that.
This is what I like about you, Chris. You go into these details in the book because if they did it back then, they had to have a return for their effort. For us today, we get power stations. Like I worked on power stations, wind farms, coal and gas, mostly in the energy industry. That's what I did. Some oil rigs too. But there was always a return for your money there. It was like you were there to make your wage or whatever you were doing, but the overall system was designed to get a return, which was an energy. And that energy was done at a large, large cost to the community.
Right.
And again, you talk in terms of what that had to be. There must have been some solid reason for that, Chris. That's what I like about what you do in the book. And that's where the Giza power plant theory really develops, I think.
Right. I mean, it's like when you are crafting that kind of precision into an object, your tools have to either be capable of no less of precision, or if you are performing the work by hand, that would have to have a much higher purpose than holding a carcass. So there has to be a special reason for it.
Yeah.
But then when it comes to hand tools and the marks that hand tools leave and the marks that machine tools leave, you find the marks of the machine tools, not hand tools. And so handwork kind of is dispelled as you examine the artifacts in closer detail.
Mm-hmm. You know, another thing is that I was looking at, and this is what I love, that the precision, because I'm an engineer, but I think in electrical terms. I think different type of engineering, Chris, but I can apply the same complex processes.
Sure.
But you know, the shafts, I never really gave the shafts much of an inkling before, but you know, the shafts built on an incline don't make any sense, do they? Because they call them air shafts. Again, another misnomer, but how difficult it is to build them shafts on an incline at such a precisional rate that's there to be measured.
Well, yeah, I mean, I don't think that the angle on those shafts varies more than half a degree anywhere along the shaft. I mean,
that's insane precision, isn't it? Right.
They were inspected by Rudolf Gantenbrink, and so he has the engineering data on that. Mm-hmm. And you can read about that exploration on his website, which is Cheops.org, www.cheops.org.
And we're going to link that all up, and we're going to link gizapower.com for your website too, Chris, on the homepage.
And I've got some articles on my homepage about the exploration of the southern shaft and the other shafts in the Great Pyramid. Mm-hmm. So, but yeah, I mean, but as far as the complexity of them, you have some of the shafts that bend around the Grand Gallery, which is another subject altogether that we could get into. Why they found it necessary to bend around, but as far as actually accomplishing that work,
I mean, they had to lay a course at a time, and then laying the course, they had to incorporate the angle and continue the angle. It just I can't comprehend that, even as an engineer. I just can't comprehend how the accuracy that, I mean... I can't even comprehend a machine to do it, like...
Right, you would have to have a flat plane, and this is what they did. They had a flat plane, mm-hmm. Where that was open to the air, mm-hmm. You know, the rest of the blocks had to be put in place. Mm-hmm. And then the channels were cut in a block that sat on that flat plane. And so, rather than have to side it or, you know, align it mm-hmm. with the blocks in place, as a closed shaft, it was done just on the flat plane, and then any adjustment could be made to that flat plane. So, but that was a remarkable feat. But now you start to cut these blocks, and you're cutting compound angles so that the blocks will fit together and shoot off at a different angle and then move back at another angle, and then still maintain that angle, the floor angle, of 38 degrees or 45 degrees, whatever it is. So, yeah, I mean, it's complicated work.
When you put it all together, Chris, you mean, the way I look at it is, these guys could do anything. These guys didn't care. Obviously, they had no concern about what way they went about it. I mean, they just done the most complex, hardest task ever. Really.
I love the comment that a architect made. His name is mm-hmm. James Hagan, mm-hmm. and he made the comment that those ancient Egyptians, they could build anything they want. He was from Atlanta. He had this southern drawl, you know, and they could build anything they want. Yeah.
You know, just going to go off topic because I mentioned the revelation of the pyramids. You also in that went into the Ramses statue and the complex 3D geometry involved in that. Just tell us a little bit about that, because that I think kind of has a bearing just before we finish up on precision engineering.
Yeah, well, I first started to kind of key into the Ramses statues at Luxor. Mm-hmm. When I was examining the crown, the conical white crown of Upper Egypt. Mm-hmm. And this crown, I completed my examinations of it, I had to conclude that it was an ellipsoid, a partial ellipsoid. Mm-hmm. Mm-hmm. And a very precise one too. Yeah. So what I was looking at was symmetry and precision.
And I love the bit you did, Chris, where you overlaid two transparent sheets and reversed them so that you could see the symmetry.
Exactly, and
that was fascinating.
I did that for for several television programs that have been on. One recently, Ancient Aliens, which was
I caught that one too. Yeah, that was lovely.
But yes, I mean that's when I first started to key into the symmetry that they were using in the statues, and then noting some of the tool marks that we find on the statues that resembled tool path that looked almost identical to the tool path that would come off a CNC machine. But when you look at the precision, the symmetry, and the geometry of these statues, you can see that they're composed of primitive solids, and these primitive solids kind of blend together, and if you would kind of do a surface map of one and bring it into the computer, you have a three-dimensional image that is very, very simple. I mean, the geometry of Ramsey's face is less complicated than the geometry of a human face, because there are fewer elements in the, or I would say diversions from a very, very smooth, rounded surface, such as if you had an ellipsoid or a ball or something like that was blended and transitioning from one radius to another. You would have fewer of those in the Ramses face as you would in a human face. So, and then the symmetry itself is incredible. How do they do that? But
totally insane. I mean, the precision just keeps coming back, and you've nailed the precision that they did on so many different levels and so many details. And I suppose the Giza power plant, you have three areas that you kind of discuss throughout the book: the precision engineering, the energies that they used for the Giza power plant, and the acoustics analysis. And I definitely want to get into some of the acoustics, Chris. Probably the granite beams is the ones that gets me, because I think that's such a definite line of inquiry where I think there's 43 granite beams above the King's Chamber, and they call them relieving beams, which again is a misnomer. This is what the Egyptologists brand them as, but they're not there for any engineering relief stress or anything like that.
Right, I mean, all you have to do is look at it, and you can see
they're somewhat freestanding, is that right?
They're freestanding. The only thing they're holding up is their own weight. And you know, they're like stringers between, across a room, you know, they're just holding up their own weight.
Yeah, and
there's nothing on the top of them.
Yeah, and you described they're roughly hewn on one side and somewhat level or flat on the underneath. Is that correct?
Well, you know, it was an interesting development for me to actually conclude that acoustics was featured significantly in the Great Pyramid, and it took a while for me to actually conclude that, or you know, to think, that is the likeliest
mechanism, probably
source of energy, or you know, force that was being exerted on those beams inside the Great Pyramid. And because of the way sound functions, and the way I look at the Great Pyramid as a gigantic musical instrument. If you consider it as a gigantic musical instrument, everything starts to
make sense.
It makes sense. Because what you have are these members above the King's Chamber. There's 5 layers of them, and you know, we could talk about the redundancy of having 5 layers, and you know how ridiculous it is to think that they had to have 5 layers so that the King's Chamber could have a flat ceiling. I mean, that just doesn't hold up. But to transfer energy from one beam to the next, you would use harmonic resonance and sound. Vibration.
Acoustics make so much sense. We've really gone into such detail with the acoustics, Chris.
And so when you look at these beams and you see that 3 sides are flat and square, with the bottom side being square, but the top is cut rough. So in some of them you have holes gouged into them, but there seems to have been more effort applied to the top surface than the other 3 sides. And the only conclusion I could come up with was that they were actually tuning them that way.
Tuning them,
so, yeah. So that they were in harmony with the rest of the beam, which is in harmony with the acoustics of the chamber itself, the King's chamber itself. And so everything was based on harmony and resonance.
Mm-hmm. You kind of had a little epiphany too, Chris, when you were in the Grand Gallery with the tape recorder. Perhaps you could just retell that story for the listeners, where you hung back after the tourists had gone. I think it was on the Ramadan day.
Right.
The pyramid was quiet. Yeah, I kind of got a sense of adventure from you in the book, Chris. That was lovely to read that.
Every trip has been an adventure for me, James. It's been an incredible journey. I mean, I've been really blessed. But this particular one was in 1995. Mm-hmm. And what I wanted to do, I wanted to see if there was any radio frequencies being emitted from the granite when they vibrated. And so I took a guitar tuner, and I also took an RF counter, mm-hmm. and I paid off the guard to keep me so I could stay in the King's chamber, and I asked him to turn the lights off. And so I was in the King's chamber after everybody left, and the lights didn't go off, and mm-hmm. And so I had the tape recorder running, and it was sitting on a granite block right near the copper. Yeah. And I crawled through, I walked down to the passageway, the horizontal passageway. Yeah. I crawled through to the Grand Gallery, and I yelled down to the Grand Gallery, "Turn off the lights!" Mm-hmm. Mm-hmm. And the sound just reverberated, down through the gallery, which is another feature that I discuss in my book, and was first noted by Napoleon, and also Paul Horn, who played his flute in the Great Pyramid at one time.
I love that analysis too. Yeah.
Yeah. So anyway, I was yelling. I yelled for the guard to turn off the lights, and then I scurried back into the King's chamber because I wanted to get by my flashlight before the lights came off. And so, anyway. After the lights were off, it was maddening to me, because one thing that I didn't think about was the reason I wanted the lights off was so that there was no electrical noise. Mm-hmm. And
interference and stuff like that.
Interference, yeah. Right. So, but when I got back in, I realized, when the lights were off, I realized that the fans were still running. Oh. So I wasn't able to get a pure reading on the RF, mm-hmm. but I did get some really interesting recordings. One was when I was walking, the tape recorder mm-hmm. picked up all my footsteps as I walked across to the passageway and crawled out. And then when I was yelling down to the guard to turn off the light, the tape recorder picked up my voice, and it was almost like I hadn't left the room.
Really?
Right. And then it picks up the sound as I'm coming back through the passageway and then walking up. But it was later on in my room that I found out that my footsteps striking the floor, I actually tested the playback on the tape recorder with the guitar tuner, and the frequency was A on the guitar tuner.
Really?
Yeah. Even my footsteps were ringing in the chamber.
It's crazy, isn't it?
Yeah. I mean, it's just amazing. But then I did some. I tried to drive the beams with my voice. I mean, people go in the King's chamber to chant in order to raise their vibrations. I went in there to chant to raise the chamber's vibrations, and so I was chanting at the resonant frequency of the chamber, and you know when you hit it. It's like when you're in a shower stall or something like that. I mean, you know when you've achieved resonance.
That's right, yeah.
And the reverberation was absolutely terrific. But what I noted back in my room, that when I was playing back the tape recorder, was that my voice was strong, but when I stopped, the reverberation was strong, but they were overtones. They were higher frequencies. Really multiple frequencies that were feeding back to the tape recorder. So, that was kind of like, all right, that's more evidence.
Things must have really opened up for you at that point with the Giza power plant theory when that happened then. You must have really clicked and put things together, I guess.
Well, it's very interesting. When I first went to Egypt, because I'd already been writing the book for quite a few years, I went to Egypt in '86. And I was actually worried. I was scared to go up to the Great Pyramid because I feared that everything that I had assumed or everything that I had read may not quite be accurate, and the thoughts that I had developed and the theory that I was developing may be proven wrong.
Mm-hmm. I understand that. I get that. Yeah.
So really, you're faced with your own. It's like looking in a mirror. Okay, this is where the truth comes out.
All your eggs are in one basket, as they say, and you're wrestling with your own concepts more than anything.
Right. So it's like, okay, am I drawn in further, or do I have to walk away? But anyway, obviously, I was inspired, and I didn't have to walk away. It's been an incredible journey, that's for sure.
And the Grand Gallery, I like your analysis with the Helmholtz resonator. I've actually studied Helmholtz magnetic fields as well, so I'm familiar with the Helmholtz. But I guess just for the reader or the listeners and readers, for just the harmonics and the resonance, probably just give that Tacoma Bridge analysis and explain the importance of resonance and really, because it's essential to the whole theory, Chris.
Yeah, well, I guess that if I could say that since the publication of the book, the resonators in the Grand Gallery, that is still an active and
exploration or concept.
Yeah, theory, yeah. Mm-hmm. I've been consulting with a physicist whose specialty is vibrational physics in solids. And
right.
So he's contacted me after reading my book, and this is a mainstream physicist who's been published in Nature and Science magazine. So you're on the right track when somebody like that calls you up. Mm-hmm. But he suggested that there were other acoustic signatures within the King's Chamber that I had not noted. Right. He also suggested that the King's Chamber itself was a Helmholtz resonator, but the other resonators needed to function within the Grand Gallery, and those resonators would respond to the vibrations coming through the pyramid. And these vibrations were created in the subterranean chamber. And it's kind of like the whole system of the Great Pyramid being a power plant, starts in the subterranean chamber, and then, and then works its way up, yeah.
But it all makes sense when you apply acoustics. That's the key thing, Chris.
It is, yeah.
We may not have it all figured out yet, but there's evidence along the way that will only make sense when you apply acoustics. I think that's the key thing.
It is, and this physicist colleague of mine, he believes that the ancient Egyptians were versed in nonlinear acoustics, which is way over my head. But it's
I've done physics with astronomy degree, and acoustics is one thing I didn't like. I have a working knowledge of it, but it's a specialist branch of physics, acoustic engineers like.
Right. Yeah. Exactly. So, so the ancient Egyptians and these structures definitely have something to teach us in our modern day, because like you started out this discussion, James, you said you don't go to that kind of effort unless you have an ROI or a return on your investment. And the artifacts are so sophisticated, they're so brilliant. I mean, the ingenuity of the engineers, scientists, craftspeople that put these things together, I mean, it displays an intelligence that probably wouldn't support the building of such a structure just for a megalomaniac of king, you know.
Yeah. And it's never been recognized really until the 90s, Chris. So probably with your book and a couple of others. I mean, we are in a shifting paradigm at the moment, but, you know, the intellectual knowledge that went into building the pyramid when we're talking about precision and acoustics, which there's a definite line of inquiry and there's definite evidence there, but it's not been recognized until the 90s really, Chris, I think. You know?
No, that's right, yeah. I mean, before my book, I'd already concluded that acoustics was the key, and so I was very keen to learn about Tom Danley's research in the Great Pyramid.
Mm-hmm.
And what he found confirmed that, yeah, it was acoustics. Mm-hmm. Because what he found was that the King's Chamber was resonating infrasonically between 2 and 9 hertz. And the frequencies formed an F-sharp chord, mm-hmm. which is really significant.
That's very significant, yeah.
Yeah. Mm-hmm. So, you know, it's all this empirical data that we need to actually find specialists to be able to model that data, you know, based on what we've been able to uncover, what we know about the dimensions, the materials, and do a full, you know, finite element analysis on it. Maybe some acoustic engineers, architectural acoustic engineers, could help in that.
Yeah. You know, things are changing in Egypt as well as we speak, and, you know, I'm hopeful. I know I was talking to John Anthony West on the show last week, and, I don't think he's as hopeful as I am, but I would like to think that if Zahi Hawass is gone now, some new guy come in, and I don't think it's going to be overturned overnight, but some more research might open up and ideas might open up. I'm hopeful anyway. I'm always the ever optimist, but
yeah, I mean, all it takes is one turn of the spade and the whole paradigm could shift. I'm hopeful for that too. You know, I mean, I didn't expect the Berlin Wall to come down either. So.
That's right, isn't it? You get these kind of spikes in society that just something changes and it all kicks off. Like,
yeah.
Chris, okay, we talked precision engineering, we talked acoustic analysis. Let's talk energies because I want to talk to you about the microwave energy and the hydrogen generator because we haven't really touched on that. I know we can't go into every little detail, but I guess probably just talk to us about the maser, the precursor to the laser, which is the microwave energy hydrogen analysis.
Yeah. I mean, I think I think when I was putting the book together, my objective was to find a comprehensive reason for all the features within the Great Pyramid.
Yeah, I like that a lot. I did like that a lot. That was good analysis.
And so we have to take into consideration everything in the Queen's Chamber, everything in the Grand Gallery, and everything that we find in the King's Chamber and above the King's Chamber. Mm-hmm. So all of these things have to kind of work together as a system.
Mm-hmm.
And so one of the pieces of evidence in the King's Chamber kind of leads you to find an answer to the purpose for the Queen's Chamber. And essentially, the evidence in the King's Chamber is what I call a waveguide, which we talked about earlier, and those are the shafts that lead from the King's Chamber to the outside.
Mm-hmm.
Well, in the northern wall, the north face, has a shaft, and the dimensions of the shaft are 8.4 inches wide and 4.8 inches high.
Mm-hmm. Mm-hmm.
And so what you have are the dimensions that would make a suitable waveguide for hydrogen, because the wavelength of hydrogen is 8.309 inches.
Yeah, very, very close to the width of the...
Right. And so it probably would have had some kind of metal liner at one time. And indeed, they did find, in Petrie's time, they found metal embedded in the outer casing stones. So at one time, they had some kind of steel or iron or, something. This was shown to be gold-plated, too, mm-hmm. which is significant, too. Mm-hmm. But it's just a very, very small piece. but how many other pieces were carted off or used for something else. This was evidently protected over the years because it was stuck between the joints of the limestone core masonry.
Mm-hmm.
So that shaft suggests hydrogen. So okay, then the question is, where did the hydrogen come from? Then we go into the Queen's chamber, and we see that we have this chamber that there was something going on in this chamber that was not going on in any of the other chambers.
This is the key to the whole power plant theory, I think.
Right. And that is, when the early explorers went into this chamber, it was encrusted with salt up to 1 inch thick on the ceiling and the walls.
Mm-hmm.
And then in 1872, Wayman Dixon discovered these shafts. But originally, the shafts didn't penetrate through to the chamber.
Right.
He only discovered them by noting a little crack in the wall, and he was able to stick a rod through this crack, and there was no resistance to it, and it went in quite deep. So he had the limestone chiseled out, and lo and behold, behind this plate that was left in the limestone block, behind that limestone was a shaft that went parallel or horizontal for a distance, and then went up on an angle. And so that shaft and another one directly opposite on the north wall, he made a similar test over there and then discovered the northern shaft. So you've got two shafts coming in, but they weren't connected with the chamber. And then in 1993, Gantenbrink sent his robot up the southern shaft, and he came against this blockage.
Mm-hmm.
And through the block, at the end of the shaft were these two metal pins.
This is the bit I love, because this makes so much sense as well.
Right. And so if you consider, we go back to the King's Chamber and we said, okay, hydrogen wavelength, where were they creating the hydrogen?
Mm-hmm.
Let's go to the Queen's Chamber. This is where they were created the hydrogen. How was that accomplished? Well, they joined two chemicals. They fed two chemicals into the chamber, and those two chemicals combined produced the hydrogen.
Mm-hmm.
Well, how do you know this? Well, because when the hydrogen boiled off, it leached salts out of the limestone and left a deposit. And then, well, how do they deliver these chemicals to the chamber? Well, the chemicals were in the shaft, and they were projected, or they spurted through these small holes, small cracks in the wall, and maybe they went into this kind of a cooling tower or something like that, or some kind of device that was able to mix them and then evaporate the fluids. So, okay, now what I did was, I'm like, okay, what if you didn't have a crack in the wall, could the water leach through the limestone plate? It was 5 inches of limestone. And then I learned, from a civil engineer who was doing a percolation test on my property, because I was having a leach field put in for a septic system. And I said, well, what do you do? Here we are in Indiana. Can you put a septic system in, say, if you have a limestone bedrock? And he said, yeah, sure. You would actually determine what the percolation rate is just by maintaining the head. Know what your head pressure is. And so I told him about this chamber in the Great Pyramid in Egypt, and he said, sure, you could measure, knowing what your head pressure was, which is the weight of the column of liquid pushing against the limestone. That would determine what your flow rate was. And that would work whether you had solid limestone or whether it was coming through a small hole in the wall. But they would have to maintain that head pressure. And how do they do that? Well, look, we have these metal pins coming through this limestone plate. And if the fluids come and they cover those two metal pins, they would create a connection.
Make the connection like a fluid switch.
A fluid switch, right.
Beautiful.
And so that's what I wrote up in the book. But also you have two chemicals. You have I have also consulted with a chemical engineer. And, he gave me the formula for creating the hydrogen.
Which then arrives at the byproduct of the salt, which again makes so much sense, yeah?
Right. So you have a dilute hydrochloric acid coming through the southern shaft. Well, what evidence do you have to show that? Well, you look at the erosion pattern on the southern shaft, and you look at the erosion pattern on the bottom part of the shaft as opposed to the upper part of the shaft, and at the bottom part of the shaft, you've got more erosion. That's because the acid would settle. I mean, it was stratified, right? And you would have a higher concentration in the lower parts than you would the upper parts. But then, when Gantenbrink's robot went up that shaft, you see all kinds of erosion on the wall. It's almost like going through a cave, And those blocks were not originally that way. And also the metal pins were eroded.
Yeah, there was evidence of
right.
The acid eating one of the pins, like in electrolysis even.
Right, exactly.
Yeah.
And then on the northern shaft, fortunately, they had another exploration in 2002. They sent a robot up the northern shaft, and they found two pins in a block at the top of the northern shaft. But these blocks had the appearance of being electroplated, where you had one that had a white coating on it, and the other one was clear. And so when you consider the chemicals involved, that makes sense. I mean, you're looking at hydrochloric acid in one, you're looking at hydrated zinc in the other one, and you got a zinc plating process going on.
And that's the key thing. It just seems to only enhance your theory the more discovery that comes on in these shafts, because
But it gets better, doesn't it?
It does. It gets better and elaborate. It becomes more elaborate, even, Chris.
The more recent exploration, they poked a snaky camera through the hole that was drilled in 2002, and they're able to look behind Gantenbrink's door.
Yeah.
And they found that the pins looped around and were kind of inserted into a hole. And then if you look at the erosion on the back of the pins, one of the pins looked like it had erosion similar to what you would find on a battery. And then they had another photograph showing the floor behind this Gantenbrink's door. And on there you have these what I consider to be electrical symbols. It looked like two connectors and a twisted pair coming out of the cable.
Right.
So, it doesn't get any clearer to me.
It only gets clearer the more research that goes on. So, Chris, you got hydrogen being generated, you're feeding energy in through acoustics, harmonics and resonance, and a possibility for this is as a microwave generator, like a microwave beam, or as I was saying, the maser, which is basically a precursor to a laser.
Right. Yes, and so essentially, obviously there has to be verification, but as an engineer, we speculate. We're just doing a brainstorming, right?
Right.
Eventually, somebody has to take it on and prove it, and some people think that person's me, but I don't have the resources to do it. But essentially, what we're talking about is a microwave signal. And the interesting thing, you started out talking about the Great Pyramid having concave sides, as though, they were a dish antenna. Well, we have microwaves striking the Earth 24/7, ostensibly from the Big Bang.
The cosmic microwave background, yeah.
Exactly.
I know this from my astronomy, you see. I did listening in class. And
what is the frequency or wavelength? What is the wavelength of that energy? It's 21 centimeters, right?
Yeah.
Right. It's hydrogen.
Yeah.
And so what you do is you collect the frequency of the signal from the Big Bang on the outside of the pyramid, and you collect as much as you can. You feed it into the northern shaft, and then it enters into the king's chamber. In the king's chamber, which has been filled with hydrogen, you've raised the frequency, you've raised the energy of the hydrogen to a higher energy state, right? And then as the signal comes in, it bumps the electron down to ground state and collects the photon energy, and then moves it onto the southern shaft. Which, interestingly, we didn't talk about the southern shaft. The southern shaft has a very bulbous opening, and when you look at it, there's a photograph in my book. It is similar to a horn antenna that you would see on a communication tower, and that is the shape of the southern shaft opening. So obviously the energy grew, and then it was directed into this opening where it was directed to the outside of the Great Pyramid.
So all roads head to an energy plant or a power plant, and there's evidence of an explosion too, Chris. Perhaps just explain that, because with this thing, the power plant probably blew up at one point in the past, and I think this is just evidence for this too.
Yes, there's one of the questions that I first puzzled over was, okay, the literature tells us that the King's Chamber had suffered a tremendous disturbance in history. It had expanded over an inch, and there were signs of the ceiling beams actually cracking along the south side. So evidently there was a huge disturbance at one time.
That had to be some serious explosion to do that.
Yes. The conventional theory once again got it wrong. The archaeologists got it wrong. They said, well,
it was an earthquake,
it was probably an earthquake.
Yeah.
So, what generally happens in an earthquake, things collapse, they don't expand.
Even though the Great Pyramid is on the most stable geological part of the planet as well.
And even though you find enormous, incredible precision elsewhere in the lower parts of the Great Pyramid, you don't find any disturbance there.
Yeah.
You have perfect
joint. It doesn't seem to hold up. I definitely agree that the earthquake theory doesn't seem to hold up.
No, there was definitely an explosion in there. And it changed the features of some of the artifacts in there. The granite box is a chocolate color now. It could have one time been the rose granite that comes from Aswan.
And is there a source of chocolate color granite anywhere in Egypt?
No, not in Egypt. No.
Where's there a source to?
Some people claim it came from the Americas or Atlantis, but that's just speculation. Mm-hmm. But then there's more evidence when you get out into the Grand Gallery, and this was a surprise to me, and it happened, and the discovery came after I had the book published, and it was in 1999. Mm-hmm. I was at a conference in Egypt, and I noted that there was damage to the walls of the Grand Gallery, and it appeared that they were in a pattern directly above the slots in which the resonators would be housed. Mm-hmm. And so that was significant. In 2001, I was back in Egypt again after they had done their cleaning. They had gone through the whole inside of the Great Pyramid and cleaned the walls. And what I didn't know before, but I could now, was the scorch marks on the ceiling. And there was one on both sides. Right above the slot, you have these very significant scorch marks. So evidently the explosion that happened in the King's Chamber affected the resonators in the Grand Gallery, and probably the whole inside, all the artifacts, all the equipment that was put in there to make the pyramid function blew up or was burnt up, or eventually was carted off in little pieces, with people wondering what they were carting off.
And the granite with the crystal content only appears around the King's Chamber, and that seems to be another very specific reason. I think you tackle everything that's an anomaly in the pyramid, Chris. That's what I love about your work and your research. You tackle the anomalous evidence, and you say at the start that it's your sheer outline going, everything has to be explained or it doesn't work at all.
Exactly.
But there's evidence for that granite crystal content was, they hoisted that up 70-ton blocks of pink granite from 500 miles away. Hoisted up how many feet high?
Well, it would be over 200 feet high when they finished it. Yeah.
Such a specific task they had to line that thing with the granite, but as you say, the crystal content was the key for that as well.
Well, the quartz crystal it's a 55% silicon quartz crystal in the granite.
That much?
Yeah. It's a very special granite. The crystalline structure of the granite is very unusual.
I remember going to the Luxor temple and looking at the pink granite statues that they carved there. You can actually see your reflection in them. They're that polished.
They're beautiful, aren't they?
Yeah, unbelievable. I've actually never been in the Great Pyramid. I've been to Egypt on 3 occasions. One was only to Luxor, and the other 2 times I was in Cairo. I couldn't get access to the Great Pyramid. I've been broken-hearted on 3 occasions.
Well, you'll have to come back with me in April.
You doing the tour? Would you believe I just said to John Anthony West, he's doing the tour, and I'm going to miss his tour. He offered me to come along, and I'm busy up until March, and I may actually have some time in April, so we do a tour for sure, Chris.
I'm doing a tour in April, and it's
what's the details for that, Chris? Call out the details for the listeners.
Well, yeah, if you want to go to my website at gizapower.com, there is a link on my homepage where you can find information about the tour.
Fascinating. Okay,
it'll be a great one. We're calling it a techno spiritual tour.
That's a nice mix there.
Yeah,
a nice mix. Chris, I could talk about the engineering aspects all day long. I really, really could. And I just wanted to get those 3 discussion topics out because it's a very complex theory and it's okay for the engineers to dissect it and jump into it. But, you seem to have covered all the facets that needed to be covered. Of course, you can't explain everything away. There could be parts still missing, Mark. But, there's 2 guys you go into in the book that I want to mention because I personally, they're a researcher's dream, these 2 guys, Nikola Tesla and Leeds Galileo. I'm really glad you mentioned, and I know you've got a deep interest with Leeds Galileo as well, like.
Yes. Actually, Leeds Galileo, I've got my sights on Leeds Galileo now. As I told you, I recently retired, and it has been my goal to fully immerse myself in his work.
Yeah, all eyes are on that for sure, Chris. That'd be interesting to see what you come up with. Because you've been to his tool shop there, haven't you?
Sure. Yeah.
No,
one of the things that I do, and I think that everybody should do when we go into other countries or we go into the space where somebody has performed work is pay respect to the ancients, respect them for what they have accomplished. And that's what I do. I try to connect with their spirit and try to, understand how they did what they did. And it's quite amazing,
That's a good outlook, Chris. That's definitely a good outlook to have.
Yeah.
Tell me this. Being obviously from Manchester, you've been to Stonehenge, yes? I presume.
I've been by it. I have not stopped there.
It's just something you mentioned about the granite beams being roughly hewn on one side, because there was acoustics analysis. I've got a guy coming on the show called Paul Devereaux.
I've heard of it.
Yeah, he's coming on the show because he wrote a book called Stone Age Soundtracks.
I've read that book, yeah.
You have read that book, yeah. I think but he did a channel, I don't know if it was somebody in the book, or else I don't know if it's Paul. They did acoustics analysis, a Channel 4 documentary anyway, and they did analysis on the Stonehenge monument, and they come up with the same acoustics analysis, that it's roughly hewn on one side and flatly worked on the other. So it's just an interesting aspect that you mentioned. That's the same. It seems to be a similar concept.
Yeah. Well, that's interesting.
Yeah.
Yeah, I'm not an expert on Stonehenge.
Nor me either. Nor me either. But it's just there's a lot of acoustics research going on at the moment. It's something I'm getting into at the moment. But acoustic research is on the increase. Archaeoacoustics is the subject I call it. Like.
Yeah. Well, the ancient Egyptians were masters. I mean, they were master acoustic engineers. That's for sure. Not just in the pyramids, but their whole culture was based on harmony and acoustics. The temples as well.
Mm-hmm. Yeah, there's I remember seeing Schock and John Anthony West, Dr. Robert Schock and John Anthony West. I've got Dr. Robert Schock coming on the show too. That's going to be quite exciting. I've got in Egypt, I've got Dr. Carmen Bolter coming on as well. So.
Oh yeah, you've got them all, haven't you?
I've got an Egypt week coming up ahead of me, but I remember them going into, I think it was the Sphinx Valley Temple, and they have these L-shaped cornerstones that seem to have no other effect than an acoustic resonance in the room.
Yes, I was with John Anthony West in 2006, and we discussed those re-entry angles where you have the stone making up part of both walls.
Yeah.
And it does appear, though, that they were. I speculate that the rough blocks were put in place and fitted together, and then the interior dimensions were applied later. The walls were cut afterwards,
right.
And so it left that little lip, little edge.
Right.
But when they sized the area, and probably for acoustics.
Right, interesting. People talk about high technology or advanced societies, and they don't like to admit that our ancients were advanced more than us. But I think you have to kind of separate and say, yes, they were more advanced in certain areas, albeit maybe masonry, construction, acoustics. People just think that they have to be either better than us in all areas, or we're better than them, or they're primitive. And it's more a complex scenario than that, yeah. I think they just maybe had the more intuitive way of doing things and applying their skill set, Chris,
Yeah, I think that it's a mistake to dismiss what we've accomplished today in terms of our technology. The ancient Egyptians were certainly doing things a little differently than we are, I believe. They had a technology or technique for lifting very heavy weights, which at least Calvin rediscovered, but we're not using today in our
he's such a small individual as well, and I think that's one thing you highlight in the book as well, that how this small little man spent so little time lifting such heavy weights. Like, he didn't have any people to help him. Like, he did it all cloak and dagger. Like,
he didn't want anybody helping him.
He didn't want anybody else to know. But,
he didn't want anybody to know how he was doing it.
What age did he die, Chris?
I think he was in the 50s.
50s. He was a young man then when he died. He was still young.
Yeah. Fairly young, yeah.
It's a shame his secrets went to the grave, isn't it?
It is, yeah, it is. And, he was from Latvia.
Yeah.
And so, he had a certain paranoia about him that inhabitants of that area have about the government, and mistrust for the government. So he and also the old Italian tile layer syndrome, where they want to keep their secrets, their trade secrets, close to their chest.
That's
and
right.
Not share them, because that was job security for them.
I do wonder, did he die unexpectedly and he didn't get a chance to tell anybody, or?
Well, I'm going on the premise that he did leave enough information for people to follow and figure it out.
Mm-hmm.
But
Well, I think if there's one man going to do that, Chris, I think you have a good as chance as anybody, considering what you've done with the Giza power plant, for sure.
Well, I can only hope.
Yeah. Well, you're very modest. You're definitely very modest. So we're just coming over the hour there, Chris. I just wanted to mention your other book. You got another book called The Lost Technology of Ancient Egypt. Is that correct?
Yeah, that's correct. Yeah.
Yeah. Well, I'd love to get you on the show to talk about that at another time, Chris. I really would. It'd be a fascinating discussion, and if I had my way and I was Zahi Was type figure, I would give you the keys to the Great Pyramid and give you all the resources that you needed to figure out whatever you could. And I would even tell you to dismantle it and put it back if need be.
Oh, you want me to do that much work, do you?
Well, if that's what it took, I just think the whole of ancient Egypt, and particularly the pyramid, for engineers, I just think,
right.
It's such a mystery there. It's such a mystery, and you provided such a wealth of research and enjoyment for other readers there too, that there is stuff there to be figured out, and you can just apply your own skill set, and you've given the confidence there for other people to go and do like-minded research too, Chris. Yeah.
Right. Yeah. I mean, I'm very happy with the state of the work as it is right now.
Yeah. Well, that's it. That's all we've got to do for the moment, Chris. So I'd love to have you back on the show at some point, and it's been a pleasure talking to you. It really was.
Pleasure talking to you, James.